So what we're going to be doing today is solving this problem here. Now, none of these are going to show up on the test. They're rarely ever seen unless you go to higher levels. In our steps, again, we're just trying to solve this for the value of x. And our first step is there one radical? If yes, get it by itself. You get it by itself. B, if no, even them out, or get them as even as possible. We want an even number on both sides. Step 2, put both sides to the nth power. And once we finish doing that and simplifying everything down as far as possible, our third step is to check and see, are there any radicals left? About wrote any twice. If so, repeat steps 1 and 2. So we've got to go back and repeat steps 1 and 2. If there aren't any left, we go to step 4 and solve. And most of the ones we've done up to this point, step 3 has been kind of a side note. We just look, see, oh, there's no radicals left, and move on. Now, as we look at this here, we do have more than one radical. So there is more than one radical, so we need to even them out. And since we have 3, the best we can do is 2 on one side, 1 on the other. So there's not a whole lot of moving that we have to do, moving things from the left and to the right. So really, we just go to step 3 and put both sides to the nth power. And because we're dealing with radicals, we're going to put both sides to the second power. We're going to square both sides. Now, for the left-hand side, that means that we're multiplying the 2 square root of x plus 1 minus the square root of 2x by itself. And we get the same thing for the square root of x minus 4. Now, the right-hand side, the square root of x minus 4 squared, because there's only one term, there's only that square root in there, the square root and square would cancel, leaving us with x minus 4. So the right-hand side's nice. The left-hand side, because we have this subtraction sign between our two terms, we are going to have to distribute this out. 2 square root of x plus 1 times 2 square root of x plus 1. The 2 and 2 will multiply together. 2 times 2 is going to give us 4 times the square root of x plus 1 squared, since it's being multiplied by itself. We'll deal with that radical and square here in a minute. Then we're also multiplying the 2 square root of x minus 1 by our negative 2x. The negative 1, which is written, not necessarily written, but understood, that negative 1 and 2 will multiply together to give us negative 2. Since the radicals are the same, they're both square roots, we're going to end up multiplying what's inside together. So we'll end up multiplying the x plus 1 and 2x together. We'll do that multiplication here in a second. Then we're going to have to multiply these terms here, our negative 2x and 2 square root of x minus 1, and we'll get a similar result. The negative 1 times 2 is going to be negative 2. And inside the radical, I'm going to have to start moving some things. We're in negative 2, square root of 2x times our x minus 1. And lastly, our negative square root of 2x times negative square root of 2x. The negative times the negative make positive. And we have the square root of 2x squared being multiplied by itself. And it's still equal to that x minus 4. Now, yes, this problem's got a little bit bigger, but it will simplify here in a second. Here, the square root and square are going to cancel, leaving us with 4 times this x plus 1, what's inside, minus 2. We can simplify this here. X times 2x is going to give us 2x squared. 1 times 2x is going to be plus 2x. Minus 2. Same exact radical. So when we do the distributing, 2x times x is still going to be 2x squared. 2x times our negative 1 is still going to be negative 2x. Make sure I didn't do a copy error because I think I did. Yes, because this should have been plus. And so that means this here is also plus. Miswrote that as a minus instead of a plus. And then lastly over here, our square root of 2x squared, well, the square root and square would cancel, giving us plus 2x. Now we still need to do this product here in the front. We're going to distribute that 4. 4 times x is going to be 4x. 4 times 1 is going to be plus 4. Since these radicals are the exact same, we can subtract the numerators, or our coefficients. Negative 2 minus 2 is going to give us negative 4. Square root of 2x squared plus 2x. And we still have our plus 2x is equal to x minus 4. Now at this point here, we do still have some like terms we need to simplify and reduce. 2x and 4x would give us 6x plus 4 minus 4 times the square root of 2x squared plus 2x is equal to x minus 4. So we've done all the simplifying on either side. We've got everything reduced as far as possible. So we've finally finished step 2. It's taken us a minute to get there, but we finished putting both sides to the nth power and simplifying where possible. Step 3, are there any radicals left? Yes. If so, repeat steps 1 and 2. So we're going to go back up to the top. Is there one radical? Yes. So we need to get this by itself. First thing I'm going to do is subtract 6x from both sides. Because our 6x minus 6x would give us 0. So we have 4 minus 4 square root of 2x squared plus 2x equals negative 5x minus 4. Still not by itself, so we would subtract 4 from both sides. These would cancel, telling us negative 4. Square root of 2x squared plus 2x is equal to negative 5x minus 8. And lastly, divide both sides by negative 4 to get that radical by itself, telling us that we have the square root of 2x squared plus 2x is equal to negative 5x minus 8 over negative 4. So we did all that to get the radical by itself. At this point, we've gone through and we've refinished step 1. We've got the one radical by itself, completely by itself. Not too concerned about the negatives at this point, especially on this side of the equation. We will have to check it at the end to make sure our solutions work. But now we can move on to step 2, put both sides to the nth power. And again, because we have square roots, we're going to put both sides to the second power. And unlike the first time we did this, the left-hand side is actually going to work out nice because the only term we have in this is the square root. We're not so much focused on the 2x squared plus 2x. That is 2 terms. But because they're chained within the square root, we don't have anything added to it or subtracted from it. We can just square it, and by doing that, we're going to cancel the square root and square, leaving us with 2x squared plus 2x equals. However, this right-hand side is going to have to be multiplied by itself. So we have to multiply this by itself, so we're multiplying the negative 5x minus 8 all over negative 4 by negative 5x minus 8 divided by negative 4. So we're having to multiply this fraction by itself. Thank you. Now let's do the denominators first, because we've got to multiply numerator with numerator, denominator with denominator. Well, negative 4 times negative 4 is 16. The numerators, negative 5x times negative 5x, negative 5 times negative 5 is going to be 25. X times x is x squared. Negative 5x times negative 8, negative and negative would make a positive. 5 times 8 is going to be 40, and we still have our x. Negative 8 times negative 5, again, is going to be plus 40x. And negative 8 times negative 8 is going to be plus 64. Combine like terms. $25x squared, no like terms, but our 40x and 40x will add together, not multiply. We're going to add those together to give us plus 80x plus 64 all over 16. Now, we need to start looking at step 3, because we've simplified both sides. We've finished step 2. Step 3, are there any radicals left? If so, repeat steps 1 and 2. There are no radicals left, so that means we can just start solving. We need to solve for x. Now, because we do have x squared in 2 different places, we will need to get this equation equal to 0. Now, one of the big things that's kind of not as nice is having this division of 16 on the left-hand or right-hand side. So to fix that, I'm going to multiply both sides by 16. Now, on the left-hand side, we're going to get this 16 times 2x squared plus 2x. And on the right side, we do have this 16 times our 25x squared plus 80x plus 64 all over 16. However, because we do have a product on top, and it's all being divided by this 16, our 16 divided by 16 would simplify out, leaving us with just 25x squared plus 80x plus 64. So this makes us and gives us, makes it and gives us an expression without a division. But we also have to do this distributing on the left-hand side. 16 times 2x squared is going to be 32x squared. 16 times 2x is going to be plus 32x. Again, at this point, we need to get this equation equal to 0. Different things we can do. I'm going to subtract 25x squared from both sides. Now, this will make us have to move more terms, but in the long run, it's going to keep that x squared term positive. 32x squared minus 25x squared is going to be 7x squared. Plus 32x is equal to 80x plus 64. We're going to subtract 80x from both sides. So we still have 7x squared, but we're going to have minus 48x equals 64. And lastly, we're going to subtract 64 from both sides, telling us that we have 7x squared minus 48x minus 64 is equal to 0. So we get to this point here. Now we do need to check and make sure our solutions or this quadratic is factorable, because we could go through the factoring steps to check and see, but it might be nice to know is square root of b squared minus 4ac, is this an integer number? And what would we be, and what we would be checking here is square root negative 48 squared minus 4 times a, which is 7, times c, which is 64. And it is 64. So what that's telling us is that our solutions are rational, and this is factorable. So the first thing I'd be looking for is a greatest common factor between these 3 terms other than 1. So that brings us to the fact, is 48 and 64 evenly divisible by 7? And the answer is no. So we'll have our 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are going to be opposite. Factors of the first term will x squared be x and x, and only factors of 7 are 7 and 1. Now our factors of 64. 1 and 64, 2 and 32. 3 is not a factor because 6 plus 4 is 10. 4, I believe that is 16. Yes. 4 and 16. 5 is not a factor because 64 is not divisible by 5. Neither is 6. 7 we already saw is not a factor, so it leaves us with 8 and 8. Now on a whole, 70 or 48 realistically compared to these other numbers is kind of small. So I'm going to try 8 and 8 to start with. 7x times negative 8, 7 times negative 8 would give us negative 56. So we'd have negative 56x. 8 times x is going to be plus 8x, and negative 56 plus 8x is going to give us negative 48x. So that does confirm these are the correct factors. And according to the zero product property, if we have 2 or more things multiplied together to equal 0, one of these has to be 0. Our 7x plus 8, we would subtract 8 from both sides. Those would cancel, telling us 7x is equal to negative 8. Divide both sides by 7, telling us x is equal to negative 8 sevenths. With x minus 8, we would add 8 to both sides, telling us x is equal to 8. So our two solutions we have are negative 8 sevenths and 8. Now the last thing we have to do before we can say we're done is we do need to check this. And to check it, we just have to plug it back in. So we have 2 times the square root of negative 8 sevenths plus 1 minus the square root of 2 times negative 8 sevenths equals square root negative 8 sevenths minus 4. At this point here, we can plug the whole thing. We can plug this entire left side into the calculator and see what it tells us. If I do this by hand, negative 8 sevenths plus 1 is going to be negative 1 seventh. That's easy to check. Negative 8 sevenths plus 1, negative 1 seventh. Minus 2 times the square root, so we have 2 times negative 8 sevenths, would be negative 16 sevenths, equals. On the other side, negative 8 sevenths minus 4 is going to be a little bit bigger number. It's minus 4, negative 36 sevenths. And now at this point we need to evaluate these radicals, but because we're taking the square root of a negative number, we do not have a real number, so this is not going to work. Because even if we tried at the start, 2 times square root of negative 8 sevenths, let's see, negative 8 sevenths plus 1 minus 2 parentheses negative 8 sevenths. It's going to tell us domain error because it is not a real number. So negative 8 sevenths does not work. Now we're going to do the exact same thing, but this time we're going to check x is equal to 8. So we have 2 times the square root of 8 plus 1 minus the square root of 2 times 8. And see if that's equal to 8 square root of 8 minus 4. And again, I can type this whole thing into the calculator, see what I get, do the same with the other side, and see if I get the same value. If we do this by hand, 8 plus 1 is 9. So we have 2 times the square root of 9 minus Square root 2 times 8 is 16. On the right-hand side, we got 8 minus 4, which is 4. Square root of 9 would be 3. Square root of 16 would be 4. And on the other side, square root of 4 would be 2. 2 times 3 is 6. Telling us 6 minus 4 is equal to 2. 2 is equal to 2. So our only solution for this here is x is equal to 8. And that's what we would do with this here if we have more than one radical. So you have this here, and that's how these would work. Now I am letting you guys do this one for bonus. It is on that note sheet. I will have them provided. If you want to get full points or you want to get all the bonus points for this here or get credit for it, you must show all your work. Show all your work. If you just give me that the answer is x equals this, I'm not giving you the points. You got to work it out. So bonus points possible.